Right, I'm just going to recap here because I want to make sure that we get this in order before we go on to looking at the base saturations and how we calculate them and look at the soil test. So we'll start again. Cation exchange capacity means the amount of negatively charged sites in the soil. Okay, the ability to hold cations. pH is a negative logarithm of hydrogen ions. The lower the amount pH is the actually higher amount of hydrogen ions. So when we see the pH in the soil, what we're really seeing is the amount of negatively charged sites in the soil occupied by hydrogen. So the base saturation, which we'll move on to next, but that is really the negatively charged sites which are occupied by cations. And those cations are the major cations in the soil, are positively charged elements that fulfill those negatively charged sites. In agriculture, we're looking at calcium, magnesium, potassium, and sodium in descending order. So to get an accurate CEC, the size of your soil, you have to have an accurate pH test, and with Brookside Laboratories we're using a 1-to-1 water extraction, which keeps the calculations in a much better defined parameters, and that is calculated in conjunction with the parts per million of the major cations, calcium, magnesium, potassium and sodium. We won't go into the equation, but when they use the equation of the pH and the amount of the major cations, then it's calculated up to the CEC, and that will be expressed in a number, and it can say starting at 4 for sand, going to 10 for silts, just for example, 15 for clays, and then right up to 40 for heavy clays and peats. So that's just a background that we need to keep in order, keep in our mind how we've come to that equation, because when we move on to the soil test and we start to calculate the amount of mineral required and look at the total amounts in the soil, this is all very, very relevant.